This webinar specifically is about getting started with Gemini 2.5 Pro. It's, I think, ideal. Something like this guide would be ideal for people that are getting started. But I think it could also be useful based on the insights for people that are already experimenting. So developers who are experimenting might also find it useful. All right, let's get going here. So table of contents for today, agenda would be going through Gemini 2.5 Pro. What is it about? What's the excitement? Then go through some summary of results, and then explore the model via the API. So what are the features? Specifically, I want to focus a bit more on reasoning. I think reasoning is going to be one of those areas where a lot of these companies are going to be putting a lot of effort and investment. So that's the area that I want to focus on today, especially when I demonstrate code and go through some use cases. And then we're going to be talking about how it integrates with the Google ADK, right? So ADK is the Agent Developer Kit. This was literally announced like a week ago. And we've been playing with it and experimenting with it, and we have an exciting example to show you there for that one. And we won't be able to touch, I think, advanced coding, long context understanding, and multimodal capabilities, but there is a section for that where I share a bit more on how we're experimenting with it and what we have found from our own experiments. Typically, what I do with these guides is we share it with, we have like an academy of people, students and professionals. They, this is how we stay up to date with things, and I help to do the research, and I help to share more insights about this stuff. So hopefully you find it useful. So what is Gemini 2.5 Pro? Right? It's a new reasoning model. It is considered like the thinking model of Google and supports native multimodality and long context window. So what I found really interesting about Google's strategy very early on is that they have always been focused on long context, right? And also multimodal capabilities, meaning that these models, the Gemini, the first, I would say, version of Gemini, when it was released, it was already multimodal, from the get-go, right? So that means that the better this model gets, the better it will get at the different modalities, right? Like audio, voice, video, images, whatever that may be. And also long context, right? So it has been trained since the early days, since the beginning, to do that really well. And it turns out that a year after, that first release or so, it is leading on all benchmarks. And it's not surprising to me, given how much energy and effort Google has spent on these two type of capabilities. Now you may wonder, why is this useful? Why do I need to care about multimodality and long context window? I think that's where everything is headed. If you have experience building agentic systems, you will know this is where this technology really unlocks so much potential, unlocks so many different kinds of applications where you can read lots of different kind of information. That's where I think the power of the Gemini 2.5 Pro model is, and that's where it's exciting. Right, so a lot of little details that I won't go through. I will skip a few of these. This is just these are just notes. You can go through them whenever you want. This model is available to experiment on Gemini, Gemini Advanced. So Gemini Advanced is, I think it's a paid product. You can test it there. You can also test it in Google AI Studio. And the great thing for developers, at least, it is available in Gemini API, right? So you can use it through there as well. I think availability to Vertex is coming very soon. I'm not sure if that has been announced. I haven't been tracking that, but that's coming soon, I believe. So in terms of results, let me just quickly jump to results here. This is just a cost chart. It's always good when you're making decisions on what model to use to always look at the cost, right? This is a good practice. Typically, because Google is one of the companies that's reducing the price of like tokens, but I think OpenAI is also competing on that front too. But typically, I find the Gemini 2.5 Pro give me the best for what I'm paying for, right? And especially this particular model. So it's definitely something that you should be experimenting with and you should be benchmarking on. This is why I wanted to do this, because I think I was mostly experimenting with OpenAI and cloud models, and then I had to kind of shift my, a bit of usage to Gemini 2.5 Pro, given how good it is for many things that I work on. So that's just the cost stuff. So this is just a result. I won't go through all of this, but I think what we can see from this result is how good this model is on different kinds of benchmarks, right? So this one in particular, this humanity last exam, is the one that you want to pay close attention to. I would say it's probably one of the hardest benchmarks, and you can see the result is not that great, it's not that high, but compared to other models, you see how it's leading there. We don't have the results for Gemini 4.1 here, we need to update that, but that was released yesterday, so we still need to update that information. But I believe this is probably one of the strongest, if not the strongest, out there in terms of reasoning, knowledge, and this is going to be one of the benchmarks that's going to tell you a lot about how powerful this model is on that. Then there's all of the other benchmarks like science, mathematics, and so on. I believe the one that's more interesting and probably more relevant to what we're going to talk about is going to be obviously the reasoning one, but it's going to be also like coding capabilities, right? So you can see Aider Polyglot. This, if you're not familiar with this one, this is the one you should be tracking along with other ones like Live Code Bench. It tells you more on how good this model is on code generation, like agentic code generation as well. Especially if you're using tools like Windsurf or Cursor, those are capabilities that matter. And I think the trend now is that it's more on how good these models are, these benchmarks, but also how practical it is, how good it is in the real world, right? Real world tasks. And so that's where a lot of focus is going on. And that's exciting because I think for some time we have been mostly focusing on like these academic benchmarks, but I think it's going in that direction now where these things are now being used more and being tested more on real world tasks. So these are just some things that I shared here, additional things, like if you want to look at the polyglot, this chart was pretty interesting. It tells you a lot about the cost efficiency here. You can see Gemini 2.5 Pro here. The cost is rather low, I would say, compared to, I think this one shows it better. This one shows you the cost and how good this model is at this particular benchmark, which is more about code editing, right? So code editing benchmark. That'll be good for tools like Cursor and Windsurf, right? When you're using those tools, there's a lot of code editing that happens by the AI. It's not just code generation. And so I think this is an important capability of this model. And you can see the percentage here, at least the accuracy here is 72.9, 73 almost here. And the cost, how low it is compared to something like Cloud 3.7, which is one of my favorite models. I still use this model for a lot of things. It's still my default model, but I think I'm now leaning more on Gemini 2.5 Pro. It's a lot cheaper. Also latency is a good thing as well for this model. And obviously the cost, right? Like and the accuracy of it. So it's a big deal. It's a big difference. So that was exciting to see this particular chart. And this is on the Aider Polyglot stuff. All right. So I've left these blocks here. So sharing just additional insights. I won't go through all of these, but just for your own reference, if you ever want to read more into this document here. This is the Search Arena leaderboard. All right. So this recently was announced. So LM6, if you're looking at results, benchmarks, for those of you that care about that, we should care because when you have all of these releases, you want to first get a good glance on, okay, where it's good at and where it's really bad at and so on. So these benchmarks kind of help gauge you there. This one is an interesting one. It's a new one from LM6, which is more on the search capabilities. So you would have products like Perplexity, for instance, right? And you will have like the Gemini, which has grounding capabilities, meaning you can use something like Google search as a tool. And that, ranks this model at #1 on this search arena. One interesting, I think, leaderboard to be tracking, especially for those of you that are building like agentic systems that have some kind of search component in it. I think search is a really interesting problem. It's an unsolved problem. And when you mix it with language models, it's quite powerful because it helps with things like, reducing hallucination and things like that. But also like search information, search results can be quite messy. And you need really good models for this to make sense out of that data. So it's twofold. I would say it's more being able to search, right, that tool and the effectiveness of that tool, and the model being able to call that tool and receive the right information. So whatever the model is instructing the search tool is important, and also how the model interprets that information and sort of summarizes that information is also really important, especially, again, as I said, when you're building these agentic systems. And I think proof of that is the recent updates on advanced deep research. If you have been following the space, right, deep research, I think, is an interesting agentic application of LLMs. And it's basically you give the model some kind of search, search task. It goes and searches the internet and it plans and it reasons about that information. Then it grabs everything and generates a report. And OpenAI popularized this particular application, but then you also have like companies like Perplexity and now Google as well. Well, Google, I think, had it early on, but it wasn't as great. However, now if you go test it, you will see how different and how significant, in terms of performance, how it has improved. It has improved significantly from what I can see from my own experiments. And so I think it's worth checking out. But this is a good example of how good it is when you mix something like a powerful model like this that can reason about a lot of information, right? Has that long context understanding, and also can make use of tools, right? Can do tool usage and make sense out of the information that the tool will send back, which in this case is Google search. So that would be a great, I think, real world application of how good Gemini 2.5 Pro is. So it's something you cannot really underestimate, because I think these type of applications are quite difficult and challenging. All right, so I'm going through these very quickly because I want to get into the code demo. I think that's the exciting part. So these are just the features available. Here's a link to that if you want to keep up to date with things. These are just the features that are supported. So we have structured outputs. Structured outputs is also another great capability if you're building with agents. This is not something that I'm going to discuss today. I probably won't have the opportunity to do it, but this is an area that I've been doing a lot of exploration on, and I've figured that, you know, if you're building agents, if you're building these pipelines that includes a lot of different components, and your agents are interacting and communicating with each other, it's really good when you can structure that information, structure the outputs, right? So that, you know, the models can, at least the agents can make sense of that information a lot better. So it's really important capability. So thinking is the one that's, you know, we're going to be focused on. There's native tool use, code execution as well. This is really nice if you want to make your LLM, you know, execute Python code and receive that information and then do something with it. This could be useful for like analysis if you're, you know, generating like charts and things like that. That would be useful. And then we obviously talk about search grounding. Then I think other exciting areas would be like image generation, like actually generating like videos and images and audio on these things. But I think that's more in the future, and that's coming, I think, eventually. See audio generation here. And there's no tuning for this one. There's no caching as well. If you want to use caching, I think the Flash model would probably be better. But again, inputs would be audio, images, video, and text, and output that's supported is just text. And you can see the token limits here, 1 million, and output token limit is 65K tokens right there. All right, so I've reached to this section here where I want to like jump into an example and go through like some code and just share more thoughts and insights into how good this model is at reasoning, what's the potential, right? What's the use cases that you want to be applying these things on? And so this is just the summary of the benchmark, which was the one I shared above, just more details about that here. And then I think I can jump into this code example now. So for those of you that, you know, want to get into code and want to try these out in the API, so I've shared some code examples here. You can access it here after the webinar. You can play around with that. But I'll just go through one of the notebooks that I've prepared and then go through some scripts as well that I've also prepared for the demo. So let's go through that first. Let's go through the reasoning part and then share some insights about that. All right, let me go through the notebook here. So the first one is going to be on reasoning, and we have shared the code for this. So let me just go here and activate this stuff. Why not just, I think the one that I use for this is going to be Gemini, this one here. And then I'm just going to go to run this code. You know, this is a fast model. Reasoning usually takes a bit of time to run. So I wanted to have this ready and have some, you know, simple examples for you here. But anyways, so if you want to get started with Gemini 2.5 Pro, there is a link that I provided in the guide as well, but you'll need to create an API key in Google AI Studio. So you would go here and then you follow the instructions there, right? You need to set up an account to get that. And once you have that, then you will paste it in your .env file. I won't show that here because that's my API key lives there, but you would just paste it there, and that's what you will be using, you know, throughout to get access to those endpoints. Yeah, basically this is how I'm retrieving that API key, right? That's very standard if you're using these LLMs. So I'm just going to go through this code. Let me see, just go through this one. So this one is just, you know, testing whether things are working. This is just Gemini 2.0 Flash. That's the model that you want to like do quick experiments on. You just use that one, and it's quite fast and it's quite good. That's all right. So let me jump to the thinking model now. So for thinking, we have, well, we have one model, which is Gemini 2.5 Pro, which is now in preview. However, this model here that you see here is the one that's built. And then this one here is the one that's on a free tier. I believe they're going to move away from the free tier eventually. And I don't know when that will come. But right now, as it is, we can still use the free tier. And I would suggest you to use the free tier since it's available there. And it's basically the same model. The only difference is that one is built and the other is not. And there are some rate limits and so on that you need to pay attention to as well. So that's provided in the guide that I shared. Okay. All right. Let me just fix things here. All right, cool. So let me test this one here. So this one is explain the concept of Occam's razor and provide a simple everyday example, very basic example, just to test this model here. Well, this one is using the, again, experimental model, right? Not using the one that's built. So this is the free one. Yeah, this is not correct. That's not correct. All right, so you can see it takes a little bit of time, right? It's thinking and it's going to generate it's going to generate an output. What is it going to generate? It's going to generate the results of that thinking process, right? So the model has the thinking and then it has like the output, the actual output, right? So it's going to use its thinking to produce the right output for whatever you were asking it for. This one basically outputs just the text, right? Doesn't have any thinking, right? And if you're using the APIs, unfortunately today, you cannot access the thinking tokens, which is a bummer because the thinking tokens usually would tell you, what's going wrong with the system, what it got wrong, and how you can improve it. If you are testing, what you can do today is you can basically use Google AI Studio. There, the model does generate the thinking. You can see the thinking steps there. And you can, that will be the way to like sort of iterate, right? Use that as a playground to iterate on your prompts and see what's working and what's not and how you can improve it. But if you're using the APIs directly, you won't get access to the thinking tokens. But you get this really long answer, right? Like what this was. I won't go through all the output here, but that's basically the idea. It's very simple. You use it very simple here, APIs and endpoints that you're using. Basically, you pass a prompt and that's pretty much it. All right, so let me go through this example now. So this one is like prompting tips. So some prompting tips I think are important as well when you're playing with these models. Some things to keep in mind, especially these reasoning models. And I think these one would apply for not just the Gemini models, but they would also apply for OpenAI models and the cloud models as well. So all of these ideas here, these prompting tips would work for that. So I've created this little function here, and this function basically is just going to do exactly what I told it to do above. And then there is this additional one that if there's some code execution enabled, if I want code execution in my in my call itself, then you have this option here where you can execute code. If not, then if that is the default is false, is just make a normal API call to the reasoning model. That's pretty much how that works. Let me just run this, make sure it's working. Okay, that seems to be working. And then here, what I want to share here is that I think this is where it gets interesting, right? How would you go and prompt these models, right? How does that work? How do you actually make them work really well for your task? I think in general, you have to start to pay close attention, especially I think for reasoning models, you want to apply them on tasks that would require a lot of information, right? So you want to think about how to structure your information, structure them properly, especially when you're doing inputs, but also when you're doing, when you're generating outputs, what is it? How do you want to structure the information? This is why I was talking about structured outputs. This is stuff that you cannot ignore. I think previously with these language models, you could get away with things like this, but as you want to apply these models on more complex tasks, you want to actually apply these delimiters. So delimiters everywhere, you can see them here, and they're really good with reasoning models from what I can see. And I mean, there's different ways how you can use delimiters, but the delimiters that work really well for reasoning models are going to be the ones that are more explicit. So you want to use like XML tags, right? And basically what the model will do is will just look at those XML tags and hopefully they are descriptive enough, what exactly you're enclosing, what is that information about? So we have some examples here. For instance, we have like menu items. This will be, I'll show you what this is in a bit. But then you have like a response because I'm structuring my information as well. So I'm going to use those delimiters for that. But anyway, so you want to make them more explicit, right? So that the model can make more sense out of these delimiters. So we have a bunch of food items in this example. Let me just, so these ones are just food items here. You can imagine you can have like hundreds and thousands of food items, right? From a restaurant, and you just plug them in here. Doesn't matter how you're obtaining this information for this demo. But when you're dealing with information like this, where you have like different attributes like price, you have like items, you have popularity here, whether it's vegan or not, there's a lot of stuff going on here that these models would typically struggle with. But now that you have a reasoning model, you can ask the model to reason more about that data and be able to provide you a more factual response. That's the idea of the reasoning model here in this application. And there's a lot of applications like that out there. So this is more in the context of a chatbot that we're trying to build. And so you see the system message here. Basically, what we're tasking is to answer questions factually about a food menu. And then we use the delimiters, right? So the delimiters are going to tell you that the food items are going to go here. So that's where the food items are. This whole thing right here that we have here is going to go down there. So we're using the delimiters there. And then here, what you see is that in this particular example, what we're going to do first, I'm going to show you how to actually do this manually. So manually means that you don't need a reasoning model, right? So for this one, we're using, the step-by-step stuff, and we're going to use the chain of thought. This is chain of thought right here. Step-by-step, please do the analysis. We're telling the model, and then, respond with the right response, okay? And we're telling it, hey, think, this is how you're going to think. This is step 1, step 2, right? And then you're going to have final response. So we're using the delimiters everywhere you can see there, and we're structuring our output. This is the output that we want from the model. And for this model, we're going to use Flash because, again, we're doing manual chain of thought. So it would make sense to use a non-reasoning model for this. So I'm going to show you. It's a lot of work, right? Because you have to detail the steps, you have to tell it the steps, you have to do all of this structuring and so on. It's a lot of work that you will put as maybe doing some, doing prompt engineering. So I wanted to show you that before I show you what's the power of the reasoning model, right? It's going to be more clear there. What's the advantage of using models like that? Anyway, so we got a response, and we got the thinking here, and we got the response. Then we can just post-process this after that, okay? That's what we would do here. But we got the steps here, and we got it from the Gemini 2.0 Flash. It means that we can do chain of thought reasoning with these standard LLMs. We can do that. However, now it has shifted a bit because now we have models like Gemini 2.5 Pro that have thinking capabilities. And now we can use that native thinking capability, which is going to be the chain of thought. And we don't have to detail out all the steps anymore. We can just ask the model, you do that part and give me the right response. So this means that it reduces the amount of work you would put upfront on designing the chain of thought prompt. That model does it by itself. It figures out based on the data that you have provided, right? Based on the instructions, that this is the right process. This is the most optimal way to think about this problem and to give you the right answer for your particular question. So just to test this out, okay, so I've tested that one out already. And then I'm going to run this one. Hopefully you can see that. Let me just enlarge that a bit more. All right. So yeah, so we're sharing. We're going to share this one here, and then we're also going to share another one because we do have. So basically, what we're doing here is we're going to. This is a live webinar. It's a public webinar, but we also have, a private group. There's more information in the guide if you want to know more about that. But there's a private group where we'll do another follow-up on Thursday that will be focused more on the Google, Agent Developer Kit. And we're going to use some of these examples again there. But so we're going to only share one of the search agents, and we're going to share this reasoning one. So you're going to get access to that for anyone who joined the webinar. All right. So this one, if you look at it, a lot shorter. I like that. Yeah, I like that it's very concise. But why was I able to do this with this reasoning model now? So the reason why I was able to do this, because now I don't need to tell it step by step. I don't need to give that instruction anymore. I can just depend on the native thinking capabilities of the model. So I tell it your task is to answer questions factually about a food menu provided below and delimited by this. Now, with reasoning models, you still want to be, sort of explicit on the high-level instructions that you want from the model. If you have any constraints, you would give that to the model. If you have a specific output that you want, you would also, detail that to the model as well, even potentially giving it examples. But when it comes to like the thinking or the step-by-step stuff, that you want to offload that to the system, right? Otherwise, you're duplicating a lot of work. So that's why I did it like this. Anyway, so you can see the response down here. There's nothing special about how I'm outputting things because I wanted to make it as simple as possible, this particular example. But then this is the first iteration. You want to start very basic. You want to start with simple questions and test the model and see how it works. And then after that, you kind of iterate on that and you kind of add more, constraints, add more complexities to your task. So what we're going to do is we're going to tell it, and for this one, if you look at it, right? So this is, I think, an interesting, like, sort of finding that I got by using this model. So for this one, you don't get the reasoning tokens. Unfortunately, you don't get that from the API. But if you're curious on what could be, a solution for something like that, what would be an approach for something like that, then, it doesn't hurt to actually try in the prompts and prompt the model and ask it, hey, can you actually just give me a step-by-step stuff, maybe even a summary potentially, and see what it gives you. So this is what I tested here. Since we're not getting those tokens, thinking tokens from the API, maybe there's another neat way to do this. So basically what I did the same task here. And the only difference now is that I told it, let's break this down into steps. And this is super helpful. Why? Because now you're instructing the model now to basically think about that and in a way forcing it to give you some steps when it's going to, do the output, right? So in the output generation part, it's going to do something like this. So it's going to say, okay, let's find the price of the mini cheeseburger step by step. Then it's going to do all of this. It's going to do this. And so in some way, what we're trying to do here is like what's called like zero-shot COT, where we don't list the steps. We just tell it, you think, and then you provide the output. But I found out that if you prompt it like this, it'll give you something like this. And it is very close to what you would get in the thinking steps, because you can test this. You can test this in the Google AI Studio. So there's all kinds of ways that you can experiment with this model. And I thought this was an interesting one to experiment with, because just giving a response like this, then I don't get the thinking steps and I don't know what the model is doing. And I wanted to kind of get a little preview of what's going on behind the scenes. Then that's what we got here. And it's very close, I would say, to the thinking tokens from my test that I did here. So let me just run this again. Hopefully it runs. All right, you can see there, it's, I was able to reproduce it. So this definitely works. So then after finding that out, then I would say, okay, let me experiment a little bit more with this, because this is interesting. And what I did here was I wanted to provide it an example of how the output should look. And this is more on the structuring of the output of the model, right? So I want to use few-shot prompting as well, which you should be thinking of combining with these models, especially when you want some desired output style and format. So that's what I have here. So it gets a little bit more complex, yes, what I'm instructing the model, but it's because I have a requirement now. I want my output to be in a specific style, in a specific format. So now we're going to add those details. Still, I don't need to give it the step-by-step stuff because I know it's going to figure that out. But I do give it this additional instruction because I still want to see in the response what's going on, right? And I'm able to leverage all my delimiters here again. And I actually gave it an example. Here is an example of the response. So this is going to be typically what the user message is going to be, the request from the user. And this is what you, the assistant, should output. So I want this to be the format of how you output, whatever you're outputting. So this is going to enforce now, force the model to basically think about this and then try to output things in the format that you want. So now I'm going to get something that is more ideal to my application. So then I could just ask it, well, this one is the one that I had before. And then I just outputted this. And because I have that now, I just basically copy and pasted it as a few-shot prompt here. And then I will say, okay, just give me the price of the chicken nuggets here. And then it's going to, you can see how this process is replicated. And it's because I like this format, actually. I think the format is great. And I tested a bit with different questions, not just the price, different questions like that. And I noticed that it's robust enough to know that, sometimes it's not just 3 steps, it's like 4 or 5 steps, and it's going to output that. You can test with it, right? You can go and test the different questions, and you'll know that you'll see that the model is smart enough. And this is, I think, where reasoning models really are different from the standard LLMs, because you can get super creative with it. You can, use them to do this type of thing that I was doing here, because that's important for me. But I guess when, Google decides to, if they do decide to make it possible to get the thinking tokens, then you don't really need to do all of this stuff, right? You'll be able to get it for free. Oh, not for free, but you'll be able to get it in the API. So I guess that won't matter too much. And then, I can avoid doing this type of thing that I'm doing here. Anyway, so the few-shot prompt example is really neat for something like this, but you can use it for many things. You can use it for what type of, output format you want, the style that you want, and so on. And you can do that with reasoning models, and reasoning models are super great at this. And that's why I wanted to show you that example. Okay. All right, great. So that's the example there. You can see down here the response. So let me test again. Do you have pizza? Let's break things down into steps. So again, I'm testing again. and see what it's going to output. This is, I think, a different request. Yeah, it's a different request here. And you can see, right, like now it gave me, this is what I was saying, like here is 3 steps, but then here is like 6 steps. So it knows from one example that this is the kind of output I want. Output things like this, and then do the analysis for me, and then generate the final response. So that's quite powerful, actually. Like if you have worked with LLMs in the past, this is pretty cool to see, because usually like these models, you know, you give it one example, it doesn't work, you have to give them like 5 to 10 examples, and then they start to kind of give you some, you know, performance improvements. But it's great that the reasoning model, you can give it one example and it knows what to do. So that's really awesome to see. Anyway, so that's the output that I got from that. Let me see what here. Which one was the one okay, this is the one I just did, I believe. Yeah, this is the one I just did. And then let's do this example here. Let me see my timing here. So I have about 10 minutes. So probably this will be the last one. But anyways, I'm sharing the notebook so you can go through it on your own. So this one is about improving reliability by verifying the responses with the model. Again, we started with very basic question. It gave us a basic output. We told it, hey, break things down. It broke things down before it responded, which was useful for my application. And then I told it, you know what, like take this example and give me in the format that I want. Great, it works really nice. And then I have one more thing that I need to do, which is really important when building applications to LLMs, which is verifying the final output. So regardless if you're using the reasoning model out of the box in the APIs and you're getting the thinking tokens, it's still very important to think about that verification part. So it's good that the model can be used this way to verify, you know, your answers, because that's going to make your model a lot more factual, and it's going to reduce issues of hallucination, especially when you're dealing with lots and lots of data that you're passing to the model. In this example, the benefits might not be so clear, but if you're giving the model, you know, tons of documents and so on, and those tokens are really large, and then there you start to see some benefits. So I'm going to run this very quickly here, and then I will jump to my agent example. I really want to show you the agent example because I think that's an interesting one. Anyway, so it's, you know, it's outputting things here. And for this one, so I did something really interesting here. And what I wanted to show also is that, you know, when you test with these prompts, you want to make it as basic as possible. You don't want to give it too much information, because what you want is you want to test what the model can do, what it can do out of the box. If it's failing at something, the format or something like that, or maybe it's not detailing all the steps how I want, then I would add that information. I would add some examples. Here, I just told it, you know, this is a structure, right? This is how you need to answer, and I don't need to give it that example anymore like I did in the previous one, like what I showed you before. So just using all those delimiters, and here we go. So we have the thinking, then we have the response, and then we have this extra step now, that's verification, and then we have a final response. So basically, if you're building this application, since the model can reason about this information in one fly here, basically I'm doing all of this in one shot. I mean, this is amazing, because if you have been building with applications, you would know that something like verification, you would have to do it separately as a separate component. But because this model has that advanced capability of reasoning about a lot of information and you know, this kind of information, then you'll be able to do that on the fly. And that's really great, because then you don't need to call the model twice. You just do it in one fly. And there's all of these little like capabilities that you can try, little creative ways on how you can use the reasoning models. That's how we're testing. That's how we're, you know, that's why we're excited about reasoning models and models like Gemini 2.5 Pro, because it unlocks all of these things that we have been struggling with, because we have to design things, you know, from the ground up, and we have to use so many LLM calls, and we have to build specialized models and even fine-tune models in some cases for things like this. And these models can do all of that. Anyway, so that was the response for that one. And I'll end it there, because I want to, well, at least this one, and I'll move to the agent one. So what is this agent about? I think we're going to add another 15 minutes to this, because I really want to go through the agent example, and I want to go through some of the questions that you're asking as well. So what is the agent about? So Google released this agentic framework, their own agentic framework, which is the Agent Developer Kit, which is the ADK for short. And this particular system, this particular framework is basically gives you some primitives on how to build like agentic systems, and very complex agentic systems, I would say. So we've started to experiment with these things, and then we wanted to share some, like an example of how you would use that agent ADK, the ADK, and how you can combine it with something like the reasoning model, right? This Gemini 2.5 Pro, and where would you even apply it? So I want to give you some ideas on how you would apply this stuff. In the guide, you will find more information on some ideas that I've shared there on how things to consider. But here I'll give you a concrete example. So let me go through that example now. Right. So with the ADK, there are many ways you can use it. It's a lot of fun to use because you can basically run it like a script, right? So you can do so for instance, we have a sequential agent. I actually took this from the docs. Basically, you have these agents that you can connect. So these are just things to configure your model and so on. But basically, you have one agent, you have another agent here, you have another agent, and you just kind of connect them. It's very similar to like Crew AI, all of these AutoGen, all of these frameworks out there. It's not that different from that point of view. And then you can just run it, right? But there's something more fun about, well, an additional feature that they added, which is what if you, and this is important because if you want to experiment with your agent, right, your agent pipeline that you built, you'll be experimenting in your terminal or something like that, and you will see the results. And you know that when you start to log things with agents, like it gets pretty messy. It's really hard to track what's going on, in that pipeline. And so you want some kind of like visual representation of your agent, right? What are the steps? What are the events? What's the session? And so on, right? What are the different states of the agent? And so they actually also released a UI, so you can check on the web how your agent is working, and you can test your agent there. I think that's a lot of, it's a huge, I would say, plus for Google, because some of the other frameworks don't really provide that. I know LangChain and LangGraph, they do provide that, but I think there are very few agentic frameworks that provide that kind of capability. And I'm excited about that because I think it has a lot of potential for debugging agents and so forth. So let me show you in action what that looks like. So here, what I'm going to do is, so let me just close this one. So I'm going to show you the search agent. This is the example. And basically what this is, what I want to use this framework for is I want to combine the different models, yes, but the Gemini 2.5 Pro, and I want to leverage its thinking capabilities. I also want to use the framework, right, to give me all of these primitives so that I can quickly experiment, create an MVP of an agentic system, and just run with experiments and see how far I can push this. And I think this is where these frameworks actually come into play. But these things, you can build them on your own. You can build your own agentic framework if you want as well. And in fact, I would encourage people to actually try that. This is something we do in our courses. We encourage you to test and experiment, write code from scratch to understand the logic, understand what these models are doing. It's also a lot of fun because you get to see, what's going on in the background as well. So with some of these frameworks, because they're so abstract, you don't get to see too much things, and you don't get to configure too many things. So you don't want that. So this one has it has two tools. Basically, they're like agents, right? So this one, for instance, is a web searcher. It has access to Google search. You can see it down here, Google search. And then you have the summarizer, which is going to summarize the results from the web searcher. So you can consider them like tools, right? Then you have the search assistant, which has access to both of these agents. So note here that because of how I'm structuring this agent, it's almost like a supervisor worker type of framework, which is sometimes called hierarchical agents because there's some hierarchy going on here. So basically, this one would be able to call upon these two agents. And on top of that, what we have done is we have added this planning component. So where am I going with this? Basically, what I want to do, this is the first version of this. I want to basically try to replicate like deep research or OpenAI deep research, something like that, where I have a planning module. It uses a planning model, it plans. And what am I going to use for that? Well, I'm going to use the reasoning model for that. This is going to be the planning component. So it's going to plan, and then it's going to be able to call this planner. The planner is going to plan a strategy on what to search, depending on what the user is asking for, what the report the user wants. And then once it has that plan, then it can access the search assistant and pass to the search assistant any information related to that search. Then the search assistant is going to use its tools to do the web search and do the summarization. So all of that information will trickle back up, right? Because it's going to, overall, this report writer is going to be like it's going to be at the top, right? It's going to be at the high level, and it's going to be calling the search planner or the search assistant to gather all of this information. They're going to work together to be able to build, the report that I'm looking for. And it's going to use Google search as a tool for web search. And that's it. And the way you connect it, so you can see down here, again, tools. as very standard here. I'm gonna access Search Planner. I'm gonna access Search Assistant. So I have these two. So you can imagine, right? Report writer, Search Planner, Search Assistant. Search Assistant has access to different tools like web search and so on. And you can add more tools to the Search Planner if you want as well. But this is the first iteration of this. And what I'm going to do, I'm going to copy this. This is the thing that I want to test. Hopefully it works. When there's a live demo, usually something goes wrong, but hopefully it works because I think the result is exciting. You can see that this took me, how much? Like 40 lines of code, something like that. Basically, what I'm going to do is I'm just going to do ADK Web, and ADK Web is just, it's going to run and going to allow me to, it's going to allow me to basically try to, to run this on the web, right? So I need to activate my environment here. 225 investor. Yeah, okay. Anyway, so I'm going to run it again, ADK Web. So this one is going to run the UI. And where am I running this command? Well, I'm running this command in this root folder right here. And this root folder has these folders. And one thing to note, right, as you go through the documentation, you have to structure your projects in this way. You need this init.py, the env as well. And you have this agent.py. Agent.py is going to have the core, the application laid out. And all of the examples look like that. Look at this one. This is a simple one. Same thing, right? So you have agent, init, and so on. So there's a structure that you need to follow for this UI to actually work. So I'm going to take this one, and then I can just go and debug and experiment with my agent. Let me see if I can go to my. All right, so I'm going to go here, and then I'm going to go here, and then test it out. Okay. All right. Cool. Yeah, just checking things to make sure everyone is, because usually there's something going on. All right. So let me share right here the search agent, right? Because I think that's super cool. Like I was able to do this. I have familiarity with the toolkit now because I've been using it since it was launched. But I don't know. I took like 1 hour to do it just because I know the primitives now and I know how to like connect. I mean, I have knowledge on how to connect this agentic system, right? Because I actually build them from scratch, so I know what I want, and that makes it easy for me to like the prompt and this and that and how to connect it and the architecture and so on. So I wanted to just do a quick MVP, quick test, right? And I think this is a fun experiment because this is probably going to be one of the hardest application of agents that you can build today, just because of like when you get web data, as I said, these models struggle to reason about that data. So that's the experiment I want to run. Anyways, I'm going to go here and let me just, I don't want to type this out again, so I just want to copy it. I'm going to take the agent. I'm going to copy this one. Hopefully it works. I'm crossing my fingers here. Hopefully it works. It's not perfect. These systems are, it's hard to reproduce results, but hopefully it's robust enough to accept this one. So it's going to be, can you give me a report on the latest model by OpenAI, GPT 4.1? We know about 4.1 release. Please include the cost, the capabilities, how it differs from GPT 4.0, and more important, depth details. So I want to report on that. Let's see what the model does. So I'm going to just ask it here. All right. So what is it doing? So basically what it's going to do is like, it has a search planner, right? And what the search planner does, right? So the report writer, which is a high-level agent, is going to call the search planner to do a planning, right? To do all the planning that it needs. This one, it will return the plan, right? And then it will call the search assistant when it needs to look for information from the web. The search assistant then uses it's not shown here. I think this is probably needs to be fixed or probably needs to be improved, but it would include, the search agent, and then it would include the summarization agent, which is going to be, this is going to be the parent to those two. But you can see already here, it's doing something. So search planner returns something right here. So you can see the plan here. Well, it's a very detailed plan. And this is great because we're using the reasoning model for this. If you wanted to structure this better, you would just do it in the prompt. But anyways, I didn't need to do that in the first iteration. So it has a lot of information here. It says, let me just read one of these. So it says, go collect information about potential OpenAI model, name GPT 4.0, and then it has this plan laid out. Like it's very long, right? And then what is it going to do? It's going to use the search assistant, and then it's going to call the search assistant multiple times, right? Depending on how much search it needs to do, right? So you can see multiple times it's calling. So it's working in the background. It's doing something. And then it's going to hopefully generate a report. So you can see all the events that's happening here. So this is really neat, right? Something you can also do is you can use tracing capabilities. I think OPIC, if you're not familiar with OPIC, OPIC is a tracing tool. We have used them. We actually have a course on that too. And you can use that one to do all the tracing if you like. I mean, you want to track the tracing, especially for this one here. What is it doing? And especially for this one too, because it's calling other agents, and you want to know that it's calling those agents appropriately and it's passing the right information, right, to those agents. So you want to actually track that. This one doesn't show that. I think it has, it has a lot more to add, but I think just as a starting point, it was good. Anyway, so we got a report. Let's see how accurate this report is. Okay, executive summary, OpenAI released the GPT 4.1, flagship model, and then some mid-tier. Okay, so it has all the different models, which is great to see. And then it says, okay, it has a cutoff right here. I didn't even know that, by the way. It's learning something here. It has so much information about cost pricing. Whether this is accurate, okay, I will need to go and check. I think this is accurate, though. I think this is probably accurate, yeah, if I remember correctly. And then you have GPT-4 Nano, right? And then it has like information about capabilities, coding, instruction following. That's correct. Long context comprehension, yes. I don't know about this one, but anyways, it has a lot of information about that. Differences from, so it looks like it followed, it followed my prompt really well, and it generated a nice report for that. So I'm very happy with this first iteration. There's many things that I could potentially improve, right? And how it writes the report, how it does different things. And I could potentially add more agents to deal with that part, right? Since this is already taking a load. Most of these, well, 2 of these agents are taking a load and doing a lot of work already. But this is exciting. For those of you that have been developing, you will know how hard it is actually to get something, to get to this point. If I really want to take something like this very serious, I would say, yes, I have many agents that I would need to add. I'll probably clean up my prompts. I'll probably be more using, more tools or something like that to just augment the results that I'm getting here. But I think as a first, iteration, it looks really good from the response. So this is really, really nice. Yeah, so cutoff June 24, so somebody verified that. That's great to see. So that's awesome. Anyway, so that's the example I wanted to share. From here, you can build on top of that, right? You can add more components to it, make it more accurate, let it do more things as well. Let it spend more time doing things. I think the planning stuff can be improved a lot. Like you can tell it more explicitly what you want in the plan. And as we said, with the reasoning model, Gemini 2.5 Pro, you can ask it a lot of things. You can ask it very complex instructions, and we'll know, how to structure that and so on. But basically, I just gave it a high-level instruction, and it just figured out, here's a potentially a good plan, but that plan could be improved. So you could use that model for that. So yes, combining these models with agentic frameworks, I think, has a lot of potential, and that's what I wanted to show you. All right, I'll end the demo there, and then I'll go for some questions. So any questions from the group? Any questions I can answer for you? I'll take those now. So there was a question here on to provide some guidance on prompts, I guess prompting to get the best result and grounding with existing information. Well, this is such a great question, because I think we most people, I think developers that I've seen develop that use some sort of search capability, they'll just assume that this model knows how to make sense out of this information. And I just showed you, right? It's not perfect. It can definitely be improved on, like, what are the details, right? What is the structure of the output that you want and so on. But I think what really matters when you're doing search information is that you want to structure that information as best as you can, right? So when you're retrieving that information from your, from your search tool, whatever search tool you're using, whatever API, you want to structure that. You want to give the model guidance on, okay, this is the type of information that you are expected to receive, and this is how you might make sense out of it. These are the type of things that I want you to actually perform on it. I think this is the kind of thing where you would require some, prompt engineering, because like the way how I built this, for instance, I didn't tell the model that. I just gave it a high-level instruction. I didn't do anything, no structuring, nothing like that. But I think it's really important to structure information. What do I mean by that? So when you get results from your, whatever search tool, I think it would make sense to maybe use a component to structure that in some kind of way. So let's say you're expected to get information about, as an example, like company information, right? When the company was built and so on. And you would want to use structure outputs for something like that, so that when the other agent receives it, in our example, it would be like the search assistant, it knows what, how to make sense out of that. If it were just to give like a pile of information to the agent, then the agent would be pretty much lost, because I mean, the information like search APIs is not so friendly, that the information that you're getting. So any type of structuring that you can add would be super helpful. That's what I was meaning to say. So that would be one. And then in the prompt itself, of agent that's receiving that information, where you're plugging that in the context, that search result, also you want to indicate or instruct the model that, hey, you're going to receive this type of information. It is coming from such and such source, and this is how you're expected to use the information. And if you cannot find some relevant information, then explicitly instruct it that it should output something else. You should output like, hey, I don't know what to do with this information, something like that, so that you get that from the model. And you can do that really well with reasoning models, right? You can instruct it with things like this. You can get pretty creative with how you're instructing it. So those are a couple of tips. But I would say, like, we covered this topic a lot in our courses. Like we actually go through some examples on this, on why it's important, when you're, it's not just search engines, but it's also like knowledge bases, databases, things like that. It's really important to spend time prompting stuff. Let me see. Okay, so I answered those ones. I have a question here. How it differs from the DeepSeek thinking process? So the whole thinking thing, the whole reasoning stuff, I think has been, it's okay. So we understand what thinking is, but the way all these models are trained are very different. Like every company uses something different to train their thinking models. I would say the data, looks a little bit similar, but how they're training it, what type of data sets, like the instructions they're using to train these models, they're going to be different, but in the end, the thinking steps that you're getting from the system are going to be of a specific structure, right? So like DeepSeek would give you like detailed thinking steps about those models. So it's not that different in what you're getting in the output, but I would say how these models are trained, are a little bit different, especially Gemini 2.5 Pro, which is going to involve like agentic capabilities, going to involve like tool calling stuff. So in the trajectories that you're using to train these models, it's going to include all of those examples. Well, it needs to include examples of that because it needs to know how to make sense of information like that. So that's kind of, I think, one important thing about this. But in the sense, like in the outputs, I think it's very similar. Like all these models, like O1, DeepSeek, and so on, they're not that different. What they're doing behind the scenes. Okay, so the better question is, how does it differ from Perplexity Deep Research or Gemini Deep Research? Well, I think this is more a question of the product, right? Like these products are now using these reasoning models, right? So we know OpenAI, for instance, is using a variant of O3 to do the reasoning. And reasoning is really what's unlocking that deep research application. Perplexity, I'm not sure what they're using behind the scenes. I think they're probably using some internal model for this. And then Gemini is using Gemini 2.5 Pro. But what does this tell us, right? This is telling us that like this is the type of application that these reasoning models are going to unlock. Without these reasoning models, it's going to be difficult to build these advanced applications. So that's the only thing I can share there. I don't know too many details about Perplexity Deep Research, but at least for Gemini and OpenAI, that's what's going on there. Okay. Yeah, so deep research models, as I was saying, they would have that thinking capability, right? So thinking means that they can receive the search information, reason about that information, backtrack if they need to backtrack. If they made an error, they will know when they made an error. They will create this plan to do all of these searches exactly how I showed you. I think this is why this application I wanted to show you is exciting and share this, because you can take this from here and go and experiment, right? You can make it specialized for a specific domain, things like that. You can make it more comprehensive in the way it plans. You can leverage Gemini 2.5 Pro to do the planning for you. Maybe you can provide more details as well. You can do a lot of things with this. Like it's a very exciting application, I think. So just go and experiment with that one. So can you replace the tools in ADK agent definitions in the example with MCP tools? Yes, I believe you can customize tools. There is a way to provide custom tools. This is something I'm going to get back in our office hours. So if you are in our office hour, if you're in our academy, I'll answer that question better there. But yes, it is possible to do that. Yeah, you can do it with functions, right? Python functions. You can do it in many different ways. So is ADK an analogous service to AutoGen, CrewAI, LangChain, etc.? Yes, I would say, and it has very similar primitives. Like you can build these multi-agents, right? As I showed, you can build sequential agents, all these different kinds of agents, agentic workflows. So from that sense, yes, the primitives, I think they're very similar, what they offer. I would say like the ADK though has, what they did was, I think it was clever because, I mean, you know, like LangGraph has been, LangChain and LangGraph and CrewAI, AutoGen, all these things, they have been very early into this space. You know, they have had to like evolve their tools. You know, the way how the primitives they're offering, how much abstraction they're giving you, and so on. But I think because OpenAI and Google came in after, you know, they were able to sort of also look at the space and see what are the common agentic patterns that actually work, right? What are the primitives that actually function in the real world, and then sort of integrate that into their library. So they might be missing a lot of things that, you know, are in LangChain or CrewAI. And it's a lot simpler from what I can see, the way how they have implemented their functionalities and things like that. But they have the right features, right? They have the right, you know, customization of tools, like you have the right, you know, the primitives, they have easy way to create multi-agent systems and things like that. So that's what I can comment there. The only thing I was a little, and plus, I would say one more thing that I'm very excited about, and I didn't, you know, get to talk about it here, but I think memory management, context management is going to be a difficult part of building agents. Like, how do you track the state, right? Save the state, make use of that state when you're building these applications, right? Let's say you have applications that runs for 30 days or something like that. You know, how does it make efficient use of its memory, long-term memory, and also memory that's maybe stored in some retrieval engine? How does it use that? Most of these, I think, tools out here, they have memory components. They have some ways on how to make easy use of memory, but I think it is not well known what are the things that actually work for memory, like memory saving, memory management, things like that. So those, I think, we will see a lot of innovation on that front. And I think they've also provided a lot of tools, like ADK has a lot of tools for memory management. And so that's an area I think that you will want to look at as well before you make a decision on whether you want to commit to this tool. Are you aware of good source for tracking the popular LLMs throughput? No, honestly, this is a good question. I think, so currently, right, we look at cost, we look at latency, but I think throughput is one of those things that we don't often talk about. And, you know, when you're building real world applications, right, time to first token is really matters as well. Throughput really matters. And there are only a few companies, you know, that actually track these type of numbers. I would say one of the companies that do this really well is Fireworks AI. Because again, there are inference engine. I think Grok also does this, you know, tracking of this type of information, and they have like benchmarks as well for this stuff. So that's where I would point you. Just go there and see if you can find something that's useful for you. But those are the companies, I think, the inference engine companies are going to be the ones that really care about this, because again, in the real world application, it really matters, right? Like it really matters what throughput you are getting from the systems and so forth. All right, cool. But yeah, but this was fun. A lot of great questions. Thank you for that. And we're going to be doing a lot of these, right? So just, you know, try to get into our mailing list or something. We're going to see a lot of these, and just go to our webinar page. There is our webinar page. And let me just open this here. I'll show you where it is. So we're doing a few of these things, webinars. All of these are free webinars. So we're going to talk about OpenAI deep research. Lots of interest in this. A lot of people in enterprise want to use this stuff, and they want to know, like, what are the use cases, right? And how do you improve deep research? So we're going to be talking about that. We also have a recording here if you want. But, you know, these are our courses. As I was talking about prompt engineering, I mean, I do believe like prompt engineering is so crucial for getting these agents to work really well. I think a lot of you would agree with that based on the questions that we received. So we have developed a few courses for no coders, and we have also developed courses for developers as well, which goes through the code. You know, I show you in code how you would implement things, how you implement your prompts, how you optimize them, and a lot of things to actually keep in mind. So I think this would probably be the best course for those of you that are developing. You know, we got some questions on structured outputs. That's a special topic. That's one that I went through a lot here. Prompt caching as well, how you leverage that. And then you have the reasoning stuff. So more details on reasoning, applications of reasoning, I think meta prompting, LLM as a judge, all of these things, right? We go through all of those things that there in terms of use case applications. But I would say the one that we're most excited about is like AI agents, right? That's the big topic. And so we're building this. We have done an early release of this course, and we're building, you know, we're showing how to implement things from scratch. It is a lot of fun because you get to see, like, how the prompt looks. You get to see like the thought process. And I'm going through these things myself, showing you in code, you know, not using any of these frameworks, showing you in code how it would work. How do you actually optimize the prompts? You know, what things to look at, how to use the delimiters or apply them. how to use the reasoning models, things like that, right? What are the common patterns that you should be thinking about with your applications? And for each one of these, we go through different like things like document generator, how to use routing LLMs, parallelization as well, for those of you that want efficiencies in your LLM applications, and some application of that as well, where it makes sense. And then we have all of these that are coming soon. So every week we release these new chapters. So a lot of very really cool content, really advanced content, I would say, in this particular course. Besides that, you can access our calendar here as well. More information on some, also the office hours that we do, because it's not just courses. We have a community behind the scenes where we have a forum. We offer support as well. We answer questions. We provide more detailed examples about use cases. If you have any in the office hours, we get to share a lot about that as well. Get to reason more about these like new models and things like that. So a lot of stuff. So I'll end it there. Thank you so much, everyone, for joining. Thank you for spending some time with us and for the great questions. Hope to see you sometime in the future in one of these events. So have a good day. Bye-bye.